Hello and welcome to the first video on energy changes. So far we've looked at the covalent bonding, Lewis diagrams. We learned how to draw our Lewis diagrams, and then we were able to use the Lewis diagrams to predict the shapes, and because we know the shapes of the molecules, we could predict the polarity and explain why things are polar or not. And then when we looked at the different solids and how what the bonding is between them, and how it affects melting and boiling points and all the other properties around it. So we've looked at all the molecular solids, we looked at covalent network solids, we looked at ionic, and we looked at metallic. So this is now the second part of our unit, and the second part is going to be around energy changes, exothermic and endothermic reactions, how to calculate the amount of energy either produced or released or absorbed in a reaction. There's a few different ways that we're going to do it, or we'll be able to explore, and then that's the end of our unit, and then we're done. So today is just a little bit of an intro on the energy changes, what it is and how we can predict it, or how we can represent it on a graph. So energy changes in chemistry, reactions happen because of energy changes. So if a reaction doesn't have enough energy to actually start happening, nothing will happen. That's why some things need to be heated before the reactions happen or take place. Others produce a lot of energy, so we can see it warms up when we add two things together, or it explodes, or it lights up, or something happens that produces a lot of energy. Others doesn't really happen, they go cold, and you need to add a lot of energy to it for it to actually take place or keep on going. So those are the two types of reactions, and the difference in the balance between the amount of energy absorbed and the amount of energy released is going to give you the endothermic or exothermic reactions. So when we talk about endothermic means it absorbs more energy than it's actually released. And exothermic is it's absorbed a little bit of energy, but it's released way more than what it's absorbed, and that's why it's called exothermic reactions. Okay, so the two things that we need to know: endothermic, more energy in, more E in than out. And exothermic, more energy out than in. Right, so those are the two: exothermic, endothermic reactions, more in and out. But when we look at reactions, it's not just whether it's a release or absorption, but in both cases, in all reactions, some energy needs to be absorbed and some energy is released always. So there's always that balance, and it just depends on which one is more or less. Okay, so when we look at endothermic, or in order for reactions to happen, energy or those bonds need to be broken. Keep this. So in order for bonds to be broken, if we look at water molecules, for instance, when we look at this equation of H2 plus O2, it's not balanced, but we'll just leave it like this. What's happening is these bonds, these two H's that's bonded together, and these two O's that's bonded together, these bonds between them need to break in order to reshuffle and then become H2O. Okay, so in order for these bonds to break, and between them, they require energy. So we need to add energy to this, or it's going to absorb energy from the environment to get this. And then when new bonds are made, all these bonds will need to release energy. So to break bonds, you need energy. And to make bonds, you release energy. Okay, so this breaking and making of bonds is this balance, like I'm referring to every time, this balance of getting energy, releasing energy, and if more of these energy, of this is needed to break the bonds than it's released, then we know it's an endothermic reaction. When it needs less energy, but it produces heaps of energy when these bonds are broken or are made, then it's an exothermic reaction. Okay, so how do we know exothermic reactions take place? And I have kind of like talked about it. When we look at an equation or a reaction and it releases a lot of heat, then we know it is an exothermic reaction. When it's a reaction that gets cold, we know it's going to be an endothermic reaction, because being cold means the fact that we're feeling it getting cold, it's taking energy from our hand and absorbing it and pulling it into the reaction, into the test tube or whatever you're holding. It's stealing energy from your hand to go into the reaction. And that is why we call it an endothermic reaction, because it's drawing energy from the environment around it for this reaction to happen. An exothermic, it's got all this energy, and it's releasing it, and energy and temperature, energy and heat goes hand in hand. So the higher amount of energy, the higher the temperature, and that's why you're feeling warm. Right, so the two ways that we can represent this endo and exothermic reaction is by putting it on a graph, because it's just easier to see. So let's have a look at what an endothermic reaction diagram will look like. So endo, so on the graph, if we look at energy on the one side, so this is going to be your energy, and this will be over time or whatever, how long it is. So if we start with a certain amount of energy, so because all substances has a certain amount of energy to start with. So if I have a little bit of energy, for this reaction to occur, remember we said we need to give reactions enough energy in order for the reaction to take place. So I'm going to add a little bit of energy. As I'm adding it, suddenly a reaction is going to happen. So we'll put this as a reaction is going to happen. And when that reaction happens, it's going to have more energy at the end. So it won't release a lot, but we've given it heaps of energy up to a certain point. And that certain point is when the reaction happens, and then at the end, this is the product, and that's the amount of energy from the product. So our reactants at the start had some energy to start with. We added heaps of energy, so we started adding a little bit of energy for it to start happening. This amount of energy that we add is called our activation energy. After we've added the activation energy, the reactions happened, and as it happened, the products have this amount of energy at the end. Okay, so when we look at this, the amount of energy, this amount of energy that I'll color in black, is called your activation energy. Okay, so activation energy. This is my end product. So we'll start, and we have the end. And the difference between the start and the end is going to be our enthalpy. So the word enthalpy just means the change in energy. And then when we look at this, when we look at this enthalpy and the change in energy, we will see that at the end we have more energy than we started. So our delta H enthalpies, the delta means change, and the H is the enthalpy, the sign that we use for enthalpy. So this will always be bigger than 0, because at the end, minus the start, we added more energy than what it had at the start. So it'll always be a positive number. Okay, so that's endothermic. We're giving it energy to start with. So we have our reactants giving it energy, adding a little bit of activation energy until the reaction happens. And at the end, our products have a certain amount of energy that's more than what they started with. And that is why our enthalpy, our delta H, is bigger than 0. Okay, so let's have a look at our exothermic reaction. So exothermic, we always also have a graph with the amount of energy at the end over time. So we start with a certain amount of energy, like we had at the start with the endo as well. And what's happening is we're giving a little bit of energy, again, activation energy. A reaction happens, and then suddenly our product's amount of energy falls, and it's lower at the end than at what we had at the start. Okay, and again, this amount of the black is called your activation energy. And the amount of energy from the difference between what we started with and what we ended with, that is going to be our delta H, our enthalpy. And if we have energy that's less than what we started with, this delta H is always going to be lower than 0. Always negative, because it's released more energy than what it started with. So it is a negative amount of energy it has. Okay, so to quickly summarize, we've got endothermic reaction. An endothermic reaction is a reaction that absorbs more energy than what it's released. An exothermic reaction is a reaction that releases more energy than it's absorbed. And to find the differences between endo and exo, an endothermic reaction will get cold, so the temperature will drop. And also, if we look at the amount of energy that we have, if that delta H, the enthalpy, is positive, we know it's an endothermic reaction. An exothermic reaction, we know, takes place when the reaction heats up, when the temperature increases, and when this enthalpy, this delta H number, is lower than 0. Okay, so those are the two. You will need to know the two graphs. They'll give you an example like a water, H2 plus O2, whatever, and say it's an exothermic reaction. Then you'll need to say the H2 and the O2 started with this amount of energy, and then it released energy, and the end product is going to be the H2O. So you need to just use these graphs and take what they give you equation-wise and pop it in there, and hopefully, make sense of the graph. So that's endo-exothermic intro all sorted. Next lesson, we'll be going into calculating what this delta H is.